Methods of calculus, specifically differentiation from first principle. Now, we only use that method when we are told that we have to differentiate from first principle. Why? Because the method is long if we were to do it for anything else. Now, the only difficulty here is to remember the formula because the formula is not in our table. So it is a limit as h is approaching 0. And then on top of the fraction, I have my function f. However, in place of x, I replace x plus h, and then minus my function f, and everything divided by h. So either you can write everything on one line, or you can break it down. I usually break it down. First, I replace x with x plus h. So that means we're going to have, instead of x here, we're going to have x plus h to the power of 2 minus 7. And again, instead of x, x plus h. And then minus 10. Take the bracket to the power of 2. Applying that formula, first number to the power of 2 plus 2 multiplied by the first multiplied by the second plus the second to the power of 2. So that's, we get x to the power of 2 plus 2x h plus h to the power of 2. And then we multiply in our bracket by minus 7. So we have minus 7x minus 7h minus 10. And that's really it. No, we can't do anything more than that here. Now in the next line, I'm just going to actually deal with the top of the fraction. So from my x plus h, I'm going to take away the f function. So I write everything that I'm having on top here. So x squared plus 2xh plus h to the power of 2 minus 7x minus 7h minus 10. Now don't forget minus here, so that means all of these items are going to change the sign. So it will be minus x to the power of 2 plus 7x plus 10. Now what will happen is that all of those elements will simplify out. Plus 10 minus 10 plus 7x minus 7x minus x squared plus x squared. You always have to have all those items simplified out. So therefore, let's go to the calculation of our limit. So limit as h is approaching 0, top of the fraction, what was left over, 2xh plus h to the power of 2 minus 7h, and then everything divided by h. So the first thing I do, I am not evaluating yet the limit, but I'm dividing each item by h. Therefore, I am left with 2x plus h minus 7, yeah? So each of those items on top of the fraction divided by h. Now, and then here we are evaluating the limit. So the key is here as h is approaching 0. So this value here of h will become really, really, really small. Okay, it will never reach 0, but it will be extremely, 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 extremely small. Let's say that's the number. So what will we say? That actually that number in comparison to 2 and 7 is insignificant. It would be 0. Therefore, evaluation of our limit is 2x minus 7. Now, going back, the reason why we are using this method only then, because if I was to differentiate that function, I know 10 will go into 0, isn't it? Here, x to the power of 1, the derivative of that is going to be minus 7, so number that stands beside x, and only x to the power of 2 have to apply the formula, and the formula is we take n in front and then power minus 1. So that means that 2 will go in front and x to the power of 1. So our derivative is 2x minus 7. So much quicker than what we've done here. That's the reason we only use that method only when it is specifically mentioned to us.